Students, good morning. Today I am going to provide a brief information about heat pumps and the refrigerator. Heat pump and the refrigerator. The brief introduction is, in nature, heat will flow from higher temperature region to lower temperature region. This is by default in nature. It does not need any kind of support or device in this circumference. But the reverse is not possible. That means transfer of heat energy from lower region to higher region. Transfer of heat energy from lower region to higher region. Is not possible by itself. Not possible by itself. It needs some special device. The device is called as heat pumps or refrigerator. Basically, heat pump and refrigerator both are identical. Only the difference is its objective. Based on its objective alone, they are different. But the function, both heat pumps and refrigerator, basically they are identical. Let us see one by one. Heat pump. Heat pump is used to transfer energy from lower temperature region to higher temperature region in order to maintain the heated space at higher temperature. This is a heat pump. HP stands for heat pump. This is used to transfer heat from lower temperature region, LTR, lower temperature region, to a higher temperature region, HTR. This HTR is heated space. This is my objective. Heated space. What you call the heated space. In order to maintain its temperature to a higher level, higher temperature level, the heat is continuously supplied to the high temperature region by using a device what you call the heat pump by means of certain amount of work. It is a reverse of heat engine. In heat engine, certain amount of heat is transferred from higher temperature region to lower temperature region through heat engine. During its heat flow, a part amount of heat is converted to useful work. The remaining amount of energy is rejected to lower temperature region. That is a function of heat engine. It is entirely reverse of heat engine. In this diagram, it says that heat pump is a device used to transfer heat energy from lower temperature region to higher temperature region in order to maintain its temperature to a higher level. This higher temperature region is nothing but heated space. What I need, the space should be maintained at a higher temperature. To maintain its temperature to a higher level, continuous supply of heat from lower temperature region to higher temperature region. This is heat pump. What next? Refrigerator. Again, refrigerator is a device used to transfer of heat, from a lower temperature region, LTR, to a higher temperature region, HTR, in order to maintain a refrigerated space. Lower temperature region is called as refrigerated space. In order to maintain its temperature to a lower level. continuous rejection of heat energy from lower temperature region or refrigerated space to its temperature lower level. Certain amount of energy is continuously removed and stored to high temperature region. Now the device is called as refrigerator. While you discuss about the heated space, the device is called as heat pump. While you discuss about the refrigerated space, the device is called as refrigerator. Clear? Right. One important thing. Heat pump and refrigerator both are not energy transferring machine. Heat pump and refrigerator, they are not energy transferring device. Are you clear? Energy transferring device means it is a heat engine. Heat engine is used to convert a part amount of heat energy into work. Heat is converted into work in heat engine. Heat engine is a energy transferring or converting device. But heat pump and refrigerator both are not energy converting machine or energy transferring device. Hence, its performance or its capacity is described in terms of coefficient of performance. While you go for heat engine, you are reporting efficiency of the heat engine. While you discuss heat pump and refrigerator, you should not use the term efficiency because these two devices are not energy converting machine or not energy transferring device. So its efficiency or performance should be discussed in terms of coefficient of performance. Coefficient of performance for heat pump is equal to how much amount of heat absorbed. This is QL, this is QH. How much amount of heat transferred to the higher temperature region or heated space in order to maintain its temperature to a higher level. Heat absorbed. That means heat absorbed. Heat absorbed divided by work done. Net work. That means QH divided by work net or QH divided by QH minus QL. This is coefficient of performance for heat pump. While you come to the coefficient of performance for refrigerator, COP for refrigerator. Listen, how much amount of heat gets removed in order to maintain its temperature to a lower level? In refrigerator, we are discussing about the refrigerated space. Its temperature should be maintained at lower level. The question is how much amount of energy is continuously rejected. Heat rejected. Here heat absorbed. Here heat rejected. Heat rejected. Divided by net work. That means QL divided by W net or QL divided by QH minus QL. This is the brief information about the function or performance of heat pump and refrigerator or working principle of heat pump and refrigerator. Thank you.